Good day everyone and welcome to our lesson about the discrete probability distribution of the chapter 2 of the probability distribution of random variables. So this is the lesson under the statistical analysis for industrial engineers. So before we proceed, so let's have our introduction. Since the 17th century, the method of probability had been used to study the physical world. Probability is now an extensive branch of mathematics. The knowledge of how manipulate probabilities to assess risk and make better decisions is important throughout scientific and engineering disciplines. In this unit, the probability distribution involving discrete random variables are presented and used to assess risks, such as in medical and engineering. This unit describes some of these standard functions, and for each one, we describe some condition under which in is appropriate. So when we are talking about the random, so this is the trial often produces number of associated with the outcome of the trial. So this number is not known beforehand. This is determined by the outcome of the trial by chance, or therefore they are so-called the random variable. No? So we have the objectives. After careful study of this unit, you should be able to do the following. Understand the assumption for some common discrete probability distributions. Select an appropriate discrete probability distribution to calculate probabilities in specific applications. Calculate the probabilities, determine means and variances for some common discrete probability distributions. So we have the type of discrete probability distribution. So we have the uniform discrete, Bernoulli, binomial, multinomial, the Pascal or negative binomial. We have geometric, hypergeometric, multivariate, hypergeometric, and the Poisson distribution. So let's have the one by one. So the uniform or discrete distribution, it is the simplest of the discrete probability distribution, is one where the random variable assume all its values with equal probability. Such a probability distribution is called the uniform distribution. So the uniform distribution gives the probability of the equal likely outcomes. So if you will notice, we have the given formula for the mean and variances, and we have the probability function. So the function of x is equals to 1 k, where k is the number of possible outcomes, where x is equivalent to number of the sample population, if kung ilan yung population natin. So we have the mean, no? So we have the, if you will notice, we have the given uniform discrete. So we have the summation of k1 I is equivalent to 1, where the this is your initial or the starting. We have this x sub I, so this is your x sub I, the number of population. So we have the k, so the total number of possible outcomes, and this will be your maximum. This will be your starting and this will be your maximum. Same with this one. Now we have the variance, so same with the given formula, the x sub I, and you have your uniform discrete, the u, dito siya kukunin sa mean, and we have the maximum, no, number of possible outcomes, and we have the total outcomes. So we have the given example. If a dice is rolled once, what is the probability of each outcome? If we're going to compute or the given formula, no? So we have the x, this will be your f of x is equals to x sub 1, no? X sub 1 is equals to 1, 2, 3, 4, 5, 6. So ibig sabihin, yung x natin is 1, no? Once lang naman kasi if the roll dice is roll once. So automatic once. over how many number of possible outcomes. So we have 6. 6 kasi diba dun sa dice natin we have 6 numbers or yung dotted numbers. So from 1 to 6. Another. So we have a single playing card is randomly selected from a standard deck of 52 cards. What is the probability of the card will be Queen of Hearts? So we have the X, no? Queen of Hearts. So syempre, isa lang naman yung ating Queen of Hearts out of 52 cards. Once lang naman siya pwedeng Next, we have the Bernoulli Distribution. An experiment often consists of repeated trials, each with possible outcomes that may be labeled success or failure. The process in this referred to as Bernoulli process, and each trial is called the Bernoulli trial. The Bernoulli trial distribution gives the probability of success of the trial in Bernoulli process. The Bernoulli process must be consist of the following properties. So letter A, the experiment consists of n repeated trials. Letter B, each trial results in outcome that may be classified as a success or failure. Letter C, the probability of success denoted by P remain constant from trial to trial. And letter D, the repeated trials are independent. So if you're going to use the probability function, so this will be your f of x is equals to n is the number of trial, and x will be the number of successes. So you have your p, the probability success, and you have your q, the failure. So with raised to n minus x, or it either na you have the number of trials and you have your c of x, the number of successes, and we have your p, the probability of success raised to x, and q raised to n minus x. Pagka kinuha mo yung min mo kanina is np. So this will be the number of trials multiplied by the probability of success. Same with your variance, the np. So number of trials multiplied by probability of success, quantity 1 minus the probability of success is equals to npq, or the number of trials multiplied by probability of success multiplied by probability of failure. So let's have a given example. Each sample of water has 10% chance of containing a particular organic pollutant. Assume that the samples are independent with regards to the presence of the pollutant. Find the probability that in the next 18 samples exactly to contain the pollutant. So let P, change of containing the particular organic pollutant, is equals to 0.10. So this is the 10%, your P. Q, chance of containing the particular organic pollutant, so that is 1 minus 0.10. Ito yung formula natin dito. This one, no? So we have the 0.90, and we have your n, the number of samples will be 18, and x random variable containing particular organic pollutant will be your 2. So ibig sabihin, so we have 18 over raised 18 to the maximum. This will be your this one, the n, and this will be your x, no? Multiply by 0.10 squared, quantity 0.90 raised to 16. So this will be equal to 0.2835. Another example. So the manufacturer of a bag of sweets claim that there is 90% chance that the bag contains some toffees. If 20 bags are chosen, what is the probability that more than 18 bags contains toffees? So let P, the change of containers, toffees is 0.90, that is the 90%. So Q, the chance of not containing 2 pieces is equals to 1 minus, or yung ano natin, failure, 1 minus P. So that is 0.10. So the number of sample will be 20. The random of variable contains is greater than 18. So we have the given formula. If we're going to follow the formula, so we have the summation of, eto yung isa-isa natin, no? For example, nag-start ka from 0, f of x is 0, f of 1 is 1, 2, 3, 4, hanggang makarating ka ng 18 and so on. So fx is equal to 19 plus 20. I-add mo lahat yun, no? So we have 20, the maximum, and we have the 19, no? So we have the 0.90 multiplied by 0.10 plus 20 over 20, the maximum and the minimum. So we have 0.90 raised to 20 quantity, 0.10 raised to 0. You're going to have the 0.3917. So we have the multinomial distribution. So whenever the binomial experiment results in more than 2 possible outcomes, this result is multinomial experiment. If a given trial can result in k possible outcomes, e sub 1, e sub 2, and so on, with probabilities of p sub 1, p sub 2, and so on, the multinomial distribution gives the probability that outcomes of e sub 1 occurs to x sub 1 times, or e sub 2 occurs x sub 2. So the ek occurs, or the x sub k times an independent trial. So we have the given properties. So the experiment consists of n independent trials, same pa rin, and we have the outcome of each trial, or the x sub I can result in any one of the predefined outcomes that can occur with their respective probabilities, or p sub I, that are constant from the trial to trial. So let's have the given notation. So if a given trial can result in outcome, so eto siya. So if you will notice, eto yun. So we have the number of outcomes, and we have your lower, yung x natin, nag-start ka from 1 and so on. Then you have quantity multiplied by p, no? Yung ating probability natin na kailangan. So we have the x raised to, hanggang kung ilan lang din yung hinihingi. So this will be your formula. So let's have a given example. So if you're going to use the scientific calculator, it is easy for you to compute, no? So this will be the factorial. Kumbaga, factorial kasi ito yung ginagamit doon sa scientific calculator. So let's have a given example number 1. A bowl has a 2 maize marble, 3 blue marbles, and 5 white marbles. A marble is randomly selected and placed back into the bowl. You do this 5 times. What is the probability of choosing 1 maize marble, 1 blue marbles, and 3 white marbles? So we have the given solution. Let n, number of marbles selected, so 5 yon, no? 5 selected marbles. And we have the number of maize marbles selected, so 1. So we have the x sub 2, number of blue marbles selected, will be 1 also. And x sub 3, we have the number of white marbles selected as 3. Kasi yun yung mga condition na hinihingi. So the probability of selecting the maize marble is 2 over 10. So paano naging 10? Kasi yung total number of marbles, we have the 5, we have the 3, and we have the 2. So the probability of p sub 1, the maize, is 2. No? 2 kasi to. 2 over 10. That is equivalent to 1 over 5. Yung blue naman natin is 3 over 10. And we have the probability for the white is 5 over 10. So that is 1/2. So if we're going to use the functional notation, so we have 5 factorial, kasi 5 yung ating number of selected marbles, no? Then you have to 1 factorial 1, and so on. and 3. So that is 1 over 5. So saan ba natin kinukuha yung 1, 1, 3 na to? This is the selected, yung x sub 1 natin. Ito yung tatlo na yun. So this is multiplied by 1 over 5, 3 over 10, and 1 over 2. Ano yung raise na yun? So ito yung condition, yung x natin. So you have your 3 over 20 is equivalent to 0.15. Another example, in a recent 3-way election for school organization, candidate A received 20% of the votes, candidate B received 30% of the votes, and candidate C received 50% of the votes. If 6 voters are selected randomly from 200 students with replacement, what is the probability that there will be an exactly 1 supporter for candidate A, 2 supporters for candidate B, and 3 supporters for candidate C in the sample? So we have n, so we have 6, no? And we have the number of candidate A, isa lang yung hininging condition. And we have the candidate for letter B, so dalawa yung hininging condition. And we have the candidate for letter C, tatlo yung hinihinging condition. The probability of voting is 0.2 kasi for candidate A is 1, no? So for candidate B, tama ba? Okay, for candidate A, there will be an exactly, no? So letter B is we have the 0.3, and we have the candidate C, we have the 0.5. So ito yun, yung 1 over 6, yung 3 up 2 over 6, and we have the 3 over 6. So kaya siya naka-point is kinuha na yung percent niya. What will be the percent? So ibig sabihin, you have 1 over 6 or 1 divided by 6, then multiply by 100%. So you have the 6, so same formula pa rin. So we have the factorial of 1 condition, yung probability 1, 2, 3, and we have the 0.2 yung ating voting candidates na 0.2, 0.3, 0.5, and this will be your x. And you're going to have the result of 0.1350. Next, we have the negative binomial or the Pascal distribution. In a series of Bernoulli trials, the concern may be finding the probability that a certain outcome will occur for the kth, or yung pinakaano niya, number. Find on the x trial which is the probability of the outcomes occurring in a constant p. The negative binomial or the Pascal distribution gives the probability that x is the number of trials until the kth success occurs. So if we're going to use the probability function, so ano lang siya, f of k, p, k and p. So you have your dx minus 1, and you have your k minus 1 multiplied by p raised to k, q raised to x minus k. So where x will be the number of trials, and k will be the number of success, and p will be the chance of success per trial. So by the given mean, you have your k over p, and for your variance is k minus quantity 1 minus p over p squared is equals to kq over p squared. So let's have a given example. Suppose the probability that a bit transmitted through a digital transmission channel is received in error is 0.1. Assume that the transmission are independent event. What is the probability that trials then result in the fourth error? So let x the number of trials on which the fourth success occurs, no, is equals to 10. Fourth ang hinihingi natin. So fourth error kasi. So ibig sabihin is equals to 10. So k the number of transmitting error is 4. That is the maximum. And we have the p chance of success transmitting error per trial is 0.1. And we have the chance of failure or not transmitting error per trial is 0.9. So that is 10. That is 0.1 minus the p, no? Doon siya kinukuha. 1 minus point t. So we have the given. So just follow the formula. Your x minus 1, and you have your k minus 1. So this will be your p raised to k, and this will be your q raised to 6. So saan po natin nakuha yung 6? So if you're going to have your 10 minus 4 is equivalent to 6. So that will be the 4.4641 multiplied by 10 raised to negative 3. So we have another example. In a clinical study, volunteers are tested for a gene that has been found to increase the risk for a disease. The probability that a person carries the gene is 0.2. What is the probability that 4 will take the tested before 2 with the gene are detected? So we have the x, the number of trials for the second success is equivalent to 4. 4 kasi yung hinihingi. No? And we have the k, the number of success detecting gene is 2. That is only 2. So we have the chance of success, the chance niya is 0.2, and we have the q, chance of failure is per trial is equivalent to 0.8. That is the formula of 1 minus the 0.2. So you're going to have your 0.8. If you're going to follow the formula, so you have your x minus 1, and you have your k minus 1, and you have your p raised to k, and you have your q raised to k, no? Raised to ano. So you have your 0.0768. Next, we have your geometric distribution. So the geometric distribution is a special case of the negative binomial distribution where k is equivalent to 1. If we continue the sample until the first success is observed, we observe x trial to get x minus 1 failures and 1 success. The geometric distribution gives the probability that x is the number of the trials until the first success occurs. So just follow the given properties. There is a sequence of Bernoulli trials except that the one of the trials is not fixed, and it is in fact that random variables of interest. So the function estimates the probability that a certain outcome will occur for the first time on the x sample value. So the probability of this outcome is a constant p. The geometric distribution is a discrete distribution taking from an infinite population. So we have the probability of function of x of p, x and p is equivalent to p raised to x minus 1, where your x is the number of trials to achieve the first success, and p will be the chance of success per trial. So if you're going to have to compute the mean, so we have 1 over p, and if you're going to compute the variance, we have the one quantity 1 minus p over p squared is equivalent to p over p squared. So let's have a given example for you to understand the geometric distribution. So the probability of a successful optical alignment in the assembly of an optical data storage product is 0.08. Assume the trials are independent. What is the probability that the first successful alignment requires exactly 4 trials? So let x, the number of trials required to get the first successful alignment, is 4. So 4 kasi yung indicated, and we have the chance per trial is 0.08. So just follow the formula. So 0.08 multiplied by 0.02 quantity raised to 3. So you're going to have the 0.0064. So let's have another example. So the probability of successful optical alignment pa rin of assembly of an optical solution data is 0.08. Assume that the trial is independent. What is the probability that the first alignment requires at most 4 trial? At most, So the number of trials is first successful alignment will be less than equal to 4, and p of the success per trial is 0.08. So if you're going to compute the summation of f of x, is less than 4, tapos ang kanyang P is 0.08. So, we're going to have your 1. Ano siya? Individual. 1, tapos 2, x sub 2, x sub 3, and x sub 4 hanggang ma-reach mo. So, you're going to have the individual computation, no? Lahat naman sila is by a given point 2, no? Kasi yung ating 1 minus the 0.08, so, ibig sabihin, 0.2, no? Pero ito, pagka pinag-add-add mo pa rin is 0.8. So, you're going to have your f of x less than to equal to 4 of your given chance of success per trial is 0.08. So, you're going to have 0.9984. So, let's have the hypergeometric distribution. So, sometimes independent trials of the sampling with replacement is not a feature of an experiment. The hypergeometric distribution is used when sampling without replacement is performed. So, the hypergeometric distribution gives the probability that out of the random sample of size n, there are x items labeled as successes, and n minus x items are labeled as failures if one of the finite population of size n, there are k successes and n minus k failures. So, we have your given probability function. So, the probability distribution of the hypergeometric random variable x, which the number of successes in the random sample of the size n selected from n, so items of which k are labeled success of n minus k are labeled as failure is. So, let's x will be the successes in the sample. Sample naman yung kinukuha natin out of the population. So, you have your k labeled successes in the population, and we have their sample size, and we have the population size. The n na malaki. Okay, so let's have a given mean and variance. For you to get the mean, so you have your n, the sample, and you have your k. So, ano ba yung ating k? The label of successes. Label of successes, and you have your total population. So, for your variance, you have your n. So, the total population minus the sample, n minus 1 multiplied by your sample, multiplied by the number of successes by the given sample over the total number of population, quantity 1 minus k over n. For you to understand the hypergeometric distribution, let's have a given examples. So, suppose we are randomly selected 5 cards without replacement from an ordinary deck of playing cards. What is the probability of getting exactly 2 red cards, either heart or diamond? So, sa 4 deck of cards, dalawa lang naman yung pinag-uusapan doon na color, black and red. So, we have the diamond and hearts for the red, and we have the club, and we have the spade for the no. So, dito, hearts or diamond, pinag-uusapan is the red card. So, let x will be the success in the sample of 2 red cards. K will be the label. So, we have the 26 red cards in a deck. So, if you're going to compute 26 out of 52 cards, so 26 yung red cards, it's either heart or diamond. So, we have the n, sample size is 5. So, 5 kasi, 5 randoms ang hinihingi sample. And we have the population size 52. 52 cards kasi yung ating basis. So, if you're going to follow the formula, so we have the 26, this will be your k, this will be your x, k, and this will be your condition. So, we have the 52 over 52 over 5 is equals to 0.3251. Itong 5 natin na to, yung hinihingi, this will be your n, no? Okay. So, eto, iniisa-isa lang. Nag-start ka from 2, then sunod ka by 3. Another example. So, suppose that the shipment contains 5 defective items and 10 non-defective items. If 7 items are selected at random without replacement, what is the probability that at least 3 defective items will be obtained? So let X will be the successes in the sample greater than equal to defective items, and we have K, the label success in the population, equals to 5 or defective items, and we have your N, your sample size is equivalent to 7, and we have your population size is equals to 15 items in the shipment. Just follow the formula or yung ating hypergeometric function. So you're going to have the result of 0.4266. Next, so we have the multivariate hypergeometric distribution. So this is a modification of the hypergeometric distribution. Instead of having only one class of interest, the population is assumed to be partitioned into K cells A sub 1, A sub 2, and so on. Which A sub 1, A sub 2, and so on are elements in the kth cell. So elements siya, no? Kumbaga, may buong sample tapos kinuwanan mo lang siya. The multivariate hypergeometric distribution give the probability that a random sample of size and yields X sub 1 elements from A sub 1, X sub 2 elements from A sub 2, and the A can. So, kung may elements ka from 1, dapat ang sub-element mo ay sa sample mo is 1A, ang elements mo will be A pa rin. A sub 1, A sub, parang ganun. And we have the probability function. So if you're going to have your given formula, so you have your initial, no, dito, with the given formula. Lahat naman yan is initial. You have your sample population, and we have the total number of observation of population. So A sub 1 is the number of item sample to fit the condition I, and AI is the number of items population to fit the condition I. N is the sample size, and N na malaki, capital N, will be your population size. So let's have a given example. So a ball has 2 maze pa rin, no? Ito yung example natin kanina. So if you're going to have a bowl, 2 maze marble, 3 blue marbles, and 5 white marbles, so kukunin natin what will be the probability of choosing 1 for marble, maze for blue, 1 for blue, and 3 for white marbles. So if we're going to have the number of population is 10, 3, 5, 3, 2 is equivalent to 10. The number of selected will be 5, no? And we have the number of maze na hinihinging condition, 1, 1, 3. Yung number of marble selected, 3 plus 1 plus 1 is equivalent to 5. So, yung A1 natin, number of maze is 2. Ito yung elements natin. Sa maze 2 kasi yung dalawang marble lang. Dalawang marble siya. Tapos yung blue ay 3 and yung white is 5. So you have, if you're going to follow the functional notation, so you're going to have the result of 0.2381. Next, let's have a sample problems, no? In dealing the hand of 5 cards from the standard deck, what is the probability, no, of they are all spade? So, eto po, yung example natin dito is halos, for the, for the multivariate, no? So, we have the number of spade of cards is equals to 13 lang naman yung tig 13 silang lahat, over 52 is equivalent to 1/4. Another, in 2 rows of dice, 6 always come up. What is the probability in getting 6 in third row? No matter how many times you throw a dice, the probability of getting 6 is does not change. Each throw of a dice independent of each throw. So, kahit ilang beses, 1 of 6 isang beses possible. The probability, 1 out of 6. Next, a dice thrown twice, what is the probability that the sum of divisible by 5? If a dice thrown twice, this matrix applicable, count the box which the sum is divided by 5. So we have the 6, no, numbers, and we have the true 6 then. So ito yung mga probability na pwedeng lumitaw. So divisible by 5 will be the number of events. So ito yon, 1, 2, 3, 4, 5, 6, 7. So total number of outcomes is 36. So bakit naging 36? Kasi dito sa 6 tsaka number of columns multiply by the number of number of columns multiply by the number of rows is equals to 36. Another example. In a recent three-way election for the school organization, yung example natin kanina. So let's have a given n. So the total n will be the total number of voters will be 200. The number of voters selected will be 6. The number candidate for one condition is 1, 2, 3. Yung condition nating hinihingi. So we have the number of candidate for voters. A is equivalent. So kunin natin yung percentage na to. Then multiply natin by the number of students. So magkakaroon sila ng result na 40, 60, and 100. Just follow the notation, the probability notation. So you're going to have the result of 0.1389. Last, we have the Poisson distribution. So we have the Poisson distribution. So the Poisson distribution is experiment yielding numerical values of random variable x. The number of outcomes occurring during the given time interval or the specific region are called the Poisson experiment. The Poisson distribution gives the probability that there will be an x object in a given region of time or space. So these are the properties of the Poisson distribution. The number of success occurring in one time interval or specified region of independence for those occurring in one or disjoint time interval of region of space. Number 2, we have the probability of single success occurring during a very short time interval or in a small region in proportion to the length of the interval does not depend on the number of successes occurring outside this time is interval or region. Third, the probability of more than one success occurring in such a short time interval or falling in such a small region are negligible. So for you to understand, so let's have the given probability function. So your x will be the number of outcomes pa rin, no, in the region or time interval of interest. You have your t, so you have your unit of time of region of interest, eto siya. So we have your range of average per unit of region, and you have your average outcome of interval region. So let's have a given example. For the case of the thin copper wire, suppose that the number of loss follow a Poisson distribution with a mean of 2.3 loss per millimeter. Determine the probability of exactly 2 plus in 1 millimeter of wire. So let x the number of loss in the region. So 2, ito yung hinihingi na sa atin. And we have your region of interest is 1 millimeter. And we have the average number of outcomes per region is 2.3. No? And we have your average outcome per region is 2.3 plus over millimeter multiplied by 1 millimeter is equals to 2.3. So just follow the scientific probability notation. So you're going to have the result of 0.2652. So another example. So the number of telephone calls that arrive a phone exchange is often modeled as a Poisson random variables. Assume that on the average there are 10 calls per hour. So what will be the probability of exactly 5 calls in 1 hour? And what will be the probability that there are 3 or less calls in 1 hour? And what will be the probability that there are exactly 5 calls in 30 minutes? For letter A, so let's have the 5 calls, yung hinihinging condition. The unit of time na required is within 2 hours, no? Ito siya, the experience is exactly in 1 hour. Pero ang condition natin dito is the 2 hours. So, saan mo kinuha yung 2 hours? So, for if we're going to have the computation, no, yung isa kasi is less than 1 hour, tapos yung isa is exactly 30 minutes. So, ibig sabihin, that is equivalent for 2 hours. So, the average call per unit is 10. So, 10. So, lahat naman sila 10 for every condition. And the average call for arrival will be 10 over 2 is equals to 20 calls. Dapat yung kanyang ma-reach. So, for the given A, just follow the scientific notation. So, you're going to have the result of 5.4964 multiplied by 10 raised to negative 5. For letter B, no, less than 3, yung hininging condition, less than 3 calls, and unit of time will be 1 hour, no, and you have your 10 calls over r. The average call in time arrival will be 10 multiplied by 1 will be 10. So if you're going to follow the scientific notation, ito is 1 by 1 kasi yun hihingi. Tatlo. 1, 2, 3. No? So you're going to have the 0.0103. And lastly, for letter C, what is the probability for 5 calls? So unit of time, 30 minutes. That is equivalent to 0.5 hours. And the number per call is equals to 10 pa rin. So 10 multiplied by 0.05 will be 5 calls dapat yung kanyang ma-reach. So if you're going to have the following condition, the probability is 0.1755. So that's the end of our lesson. This is lesson 3. So that's the end of our lesson 3, and I hope you learn much from this topic. Thank you and have a nice day.